Now we will do some problems which are based on rate of change. So the first one is the rate of change of volume of a sphere with respect to time is 16 pi centimeter cube per second. Find the rate of change of its surface area with respect to time at the moment when the radius is 2 centimeter. So, here we have rate of change of volume of a sphere. The solution is, let V be the volume of sphere, R be the radius of sphere, and capital S be the surface area of a sphere. So as we know that we have rate of change of volume with respect to time is 16 pi centimeter cube per second. That is dV over dt is 16 pi centimeter cube per second. So next, as we know that volume of the sphere is 4 by 3 pi r cube. That is, we have to find derivative of V with respect to t. So it becomes 4 by 3 pi dr by dV by dr, that is 3r square into dr by dt using chain rule. dV by dr into dr by dt, because V is not the direct function of t. So here also we have dV by dt is 16 pi centimeter cube per second, and we have 4 by 3 into 3r square dr by dt. From this we have dr by dt is equal to 4 by r square centimeter per second. By 3 is cancelled out by 3, 4 times 4 over r square. Pi is cancelled out by pi. So we have dr by dt is 4 by r square. How does unit come? That is dr by dt centimeter per second. Now surface area of a sphere, that is S is equal to 4 pi r square, and we have to find the rate of change of surface area. Therefore, ds by dt is equal to 4 pi same ds by dr into dr by dt. So we have 8 pi r into dr by dt. In problems, we have to find the rate of change of its surface area with respect to time at the moment when the radius is 2 cm. So at r is equal to 2, what is the value of surface area? That is rate of change of surface area, that is ds over dt at r is equal to 2 is equal to 8 pi into r into dr by dt, that is 4 by r square, that is 4 by 2 square. It gives 32 pi centimeter square per second. 8 2s are 16, that is 4 over 4, 64 over 4. So we have here 16 pi centimeter square per second. That is our required answer. That is rate of change of surface area with respect to time. Now the next problem is, that is number 2. Air is being pumped into a spherical balloon so that its volume increases at the rate 80 centimeter cube per second. How fast is the radius of balloon increasing when the diameter is 32 centimeter. So first of all we will see what we have in this question. That is, first of all we have volume increases at the rate 80 centimeter cube per second. That is rate of change of volume with respect to time. That is centimeter cube per second. So let V be the volume of spherical balloon and R be its radius. And its volume increases, that is dV over dt. Increases means plus sign. Plus sign indicates it increases at the rate 80 centimeter cube per second. That is, as we know that volume of a spherical balloon is 4 by 3 pi r cube, and we have dV by dt. So we will find out the rate of change of volume with respect to time. That is dV over dt gives 4 by 3 pi 3r square dr by dt. From here we get, by comparing, 80 is equal to 4 by 3 pi 3r square dr over dt. Here 3 is cancel out and we will get dr over dt is equal to 80 over 4 pi r square centimeter per second, as a unit of radius is centimeter and time is second. So we have diameter, that is 2r, that is diameter, that is 32. It gives radius is equal to 16 centimeter. So we have to find here how fast is the radius of balloon increasing. That is, we have to find the rate of change of radius, that is dr by dt, when the diameter is 32. That is when the radius is 16. So we are near to our solution. So at r is equal to 16, dr over dt is equal to 20 over pi r square is equal to 20 over pi into 16 into 16. So add the table of 4, 4 are 16, 4 5s are 20. So that gives 5 over 16 into 4, 64 pi. So rate of change of increase of radius with respect to time is 5 by 16, 5 by 64 pi centimeter per second. So it is the rate of change of radius with respect to time. So the next problem is to be discussed is there, that is a ladder 5 meter long is leaning against a wall. The bottom of the ladder is pulled away along the floor. Away from the wall at the rate 3 centimeter per second. So how fast is its height on the wall decreasing when the foot of the ladder is 4 meter away from the wall. So first of all, see here, a ladder is leaning against a wall and let its distance from the wall is y and height is x. That is solution. So we assume this is the floor and this is the wall along positive y-axis. So ladder is placing here. Which is at a distance y and which is at this height x. This is ladder and this is wall. So if we see here, we name it as A, B and C. If we see here, AB is wall, part of wall, not wall, this is a part of wall, and C, point where ladder touches the ground. And length of ladder is given, that is 5 centimeter. 5 meter. We suppose L is equal to length of ladder, that is 5 meter. And here we have the bottom of ladder is pulled away along the floor away from the wall at the rate of 3 centimeter per second. That is, there is a rate of change in the y. Therefore, dy over dt is 3 centimeter per second. And we have to find that as we see that as it is pulled away, height will be decreased. If it is at this point, then ladder will become this. If it is at this point, ladder will become this. So height goes on decreasing. Therefore, we have to find dx over dt. If we see from figure, triangle ABC is a right angle triangle. Therefore, by Pythagoras theorem, x square plus y square is equal to x square. That is by Pythagoras theorem. That is base square plus height square is equal to hypotenuse square. That is we get x square plus y square is equal to 25. L square is 25. So now differentiate it with respect to t. We get 2x dx over dt plus 2y dy over dt is equal to 0 as 25 is constant. So from here we get 2x over dx over dt is equal to minus 2y dy over dt. That is, as we have dy over dt 3 centimeter per second, we have to convert centimeter into meter as the length of ladder is 5 meters. So we divide it by 100 to convert centimeter into meter per second, as 1 meter is equal to 100 centimeter. So 1 centimeter is equal to 1 over 100 meter. So by converting dy by dt, we will find dx over dt is equal to minus y over x into dy over dt. And dy over dt is 3 over 100. So if we see in the question, we have how fast is its height on the wall decreasing when the foot of the ladder is 4 meters away from the wall. That is, what happened when y is equal to 4. So what is the value of x at that point? We have already x square plus y square is equal to 25. So from here, x square is equal to 25 minus y square, that is 16. So from here we will get x is equal to under root 9. Since it is a length, so negative value is rejected, we get only 3 meter. So dx over dt is equal to minus 4 over 3 into 3 over 100 meter per second. That is, we get minus 4 over 100 meter per second. That is minus 0.04 meter per second. Here minus sign indicates decrease in quantity, rate of decrease of quantity. So, height of ladder decreasing at the rate